In this video, we'll be going over the iterative approach of binary tree in-order traversal. Let's go over the thought process. The direction of an in-order traversal is left, roots, and then right subtree. We will need a way to mimic the recursive call stack. This can be done using a stack data structure. Now for each of the node x, we will want to process the nodes on the left side of x before we process x. Let's go over the pseudocode. So we're going to create a stack to implement in-order traversal, but before that, let's validate the input parameter. If roots is null, this means there are no node values, so we can return an empty list. We're going to create a stack to implement in-order traversal, and then we're going to create a list results to keep track of all node values. Then we're going to push all of the nodes on the left path of roots into the stack. Because we want to process the left subtree first, so we want to push off the left nodes first, just on the left path. So while stack is not empty, this means we still have nodes to process. We're going to pop a node from the stack. We're going to add the node.val to our resulting list. Now we want to process the right subtree of node, but before that we need to process all of the nodes on the left first, because even if we're going on the right subtree, we still need to process the left side of the right subtree first. So I'm going to push node.right and all of the nodes on the left path of node.right into the stack. Then we can return our results. Let's go over the time and space complexity. So the time complexity is O of n, where n is the total number of nodes in the input tree. We visit each node once, and our space complexity is O of n plus O of h. So let's go to O of n, where n is the number of nodes and h is the height of the input tree. So first O of h is our stack, and O of n is our resulting list. Let's go over the code. So we're first going to validate the input parameter. If the tree is empty, so we can just return an empty list. Now we want to create our stack to keep track of all of our nodes. And then we're going to create a list to keep track of all node values. And then we're going to push all nodes on the left path of roots first into the stack. And then while stack is not empty, we're going to pop a node from the stack. And then we're going to add the value of the node into a resulting list. Then we're going to push all of the nodes on the left path of node.right, including node.right. Then we can return our results. Now let's create our method to push all of the nodes on the left path, including the current node. And then we have our stack. We iterate through for tree node is equal to the current roots, node is not equal to null, and we just move toward the left path. Node is equal to node.left. And then we can do stack.push node. Let me know if any questions in the comment section below.